Quantum theory doesn't tell you yes or no. It may tell you, oh, it clicks with 70% probability. Even if you know everything there is to know about the world, some events you cannot predict whether they will happen or not.
Computation, bit strings, algorithms. You might suppose you're hearing a description of a computer. You'd be mistaken.
What if you're a pattern for a bunch of data in some sense? What pattern will you be next?
Markus Müller is a theoretical physicist and research group leader at the Institute for Quantum Optics and Quantum Information in Vienna. He proposes a groundbreaking theory called Algorithmic Idealism, a mathematically rigorous approach that positions observer states as fundamental.
Everybody's dreaming, but the dreams are correlated.
And the so-called objective external world, a probabilistic handshake between observers.
As you already explained, I'm not claiming that the world we see around us is not real or just an illusion. It's more a claim that it's not fundamental, and it's a different approach where you start, with the first person, with you, right?
So what comes first, the observer or the observed? Here's Markus Müller. Welcome to the Quantum Theory Podcast.
Markus, thank you so much for joining me this evening over in Austria. I really appreciate the time.
Well, thank you for having me. I guess you were on the West Coast somewhere?
Yes, over here in Arizona, so it is morning for me.
Well, that's far away.
Well, we have a lot to cover today. You have an extremely interesting perspective, I should say more broadly on reality, but even particularly with algorithmic idealism that I'm really excited to explore further and kind of break down for the audience. Before we get into more of the nuances and complexities and Boltzmann brains and all of that good stuff, I would love to firstly to start by laying some foundations. And I think someone such yourself that is at the Institute for Quantum Optics and Quantum Information is quite qualified to speak on the quantum world. And so I'd love just to firstly hear your perspective on how the advent of quantum theory has challenged or even perhaps altered our perspective of an objective external world.
So I would say to appreciate this, you have to compare quantum theory to the sort of physics we had before, which was classical physics. Classically, when you have like a billiard table and you see your billiard balls that have certain positions on the table and that move around with certain velocities, you know exactly what's going on. And you see the balls, you can perfectly predict when and where they will hit each other. And the equations of classical mechanics tell you all that. And they talk directly about these balls, their positions and their masses and everything like that. Now, in quantum theory, however, it turns out that quantum theory doesn't give you that. So it only gives you what's called a wave function, but the wave function is something that you can only use to compute probabilities. So, for example, we say here's a substance and here's a Geiger counter, a radioactive substance, and maybe the Geiger counter clicks. So I want to know whether it clicks or not within the next second or so. In quantum theory, it doesn't tell you yes or no. It may tell you, oh, it clicks with 70% probability. And that's actually the best you can do. Like, even if you know everything there is to know about the world, for some events, you cannot predict whether they will happen or not. So physicists like to talk about measurements and their outcomes. So your measurement would be you just, here, is it clicking or not? And whether you have a click outcome or not is probabilistic. It's not deterministic. Now, certainly my colleagues and I, we're all involved in debates, what all that really means. So you can have many different ideas about what quantum theory tells you about the real world. So maybe we live in a sort of multiverse, maybe an Emergence, believe in many worlds, or maybe you believe that there's a kind of hidden pilot wave that moves stuff around. But in the end, that's just stories we tell. And I'm not so much interested in these stories because in the end, it's about the phenomena. And one phenomenon that we cannot argue about is technologically, for example, right? Quantum theory allows you to build quantum randomness generators where nobody can predict what they will generate, right? Which is impossible in classical physics. And I think regardless of the debate, all my colleagues agree it makes sense to produce them and to buy them. And yes, nobody can predict whether they will click or not. no matter what that actually tells you about the world. But that's a way, determinism versus non-determinism, I think, in which quantum theory is different and new in a way.
And further on that, I would kind of extend that question to ask, why is an information theoretic perspective more so important to understanding reality? Because I know that's a big aspect of your approach. So if you don't mind shedding some light on that as well.
Right. So you can say that a lot of the developments in the last decades that have shed light on quantum theory come from quantum information theory ultimately. And in quantum information theory, you take the idea seriously that a quantum state isn't a thing in the world like an electromagnetic field. It's more something like a probability distribution. It's something that tells you, for example, the probabilities of whether you find one outcome or the other. And so, like in classical probabilities, information theory is the game in town. So is it quantum information theory now? So we try to understand the sort of correlations, probabilities, and the behavior that quantum systems can have in information theoretical language. And that's often a better language than the intuitive one. So, for example, when you think of a double slit experiment, we have a particle that impinges on one of two slits, right? Classically, you'd say, well, it's just going through one or the other, right? And I can talk about the trajectory. It's going to the left and passing there and hitting the screen. But in quantum theory, you find that it's probably impossible to say that it goes through one or the other, right? So if you assume, oh, maybe it goes through the left or through the light strip, you just don't know which one, then this typically leads to wrong predictions. This cannot be the case. But what we see is a spot on the screen in the end, right? So we have an outcome that we see with a certain probability, and we cannot say what exactly happens in between, but we can use information theoretic language. It's like a communication. There was a sender and a receiver, perhaps. So, and this turned out to be immensely powerful and lead to technological applications that we have nowadays and maybe more in the future.
And how can the audience grasp information? Because I feel it's kind of a slippery concept. And when we talk about the foundation of reality, or more of a Wheeler perspective, the it from bit sort of concept, how can we conceptualize what information fundamentally is and its primacy in reality?
So I guess the word information itself can have very many different meanings. It's just a word, right? But if you want to use it in physics or economy or wherever, you have to say more clearly what you mean. And there are many different versions of it. So there is a big zoo of different information measures, for example. And I guess for our discussion here, there are two versions of information, broadly speaking, that are relevant, that are to be distinguished. One is information that has to do with probability theory. So in probability theory, you may toss a coin and may say, oh, there's a 50-50 probability of finding heads or tails. And then maybe you look and you see what the outcome is. So you find one bit of information, maybe, oh, it's heads. But maybe your friend hasn't seen it yet. So your friend may still assign 50-50 probability, and he or she doesn't hold that bit of information. So this is a notion of information tied to probability. And there's things like Shannon information from Neumann entropy are things where it tells us how much information there is in some system. But there are other versions. And one other important one is where information is just data. So think really of the bunch, like the zeros and ones on your hard drive in your computer. That's just an actual number of outcomes or bits that you have. And there, things like Kolmogorov complexity are information measures. They tell you how sort of intricate is the pattern of bits that's concretely in front of you. How much could you compress this information, for example? How much space do you need to store it? But these are just two examples. And both of them, and in particular, the first one that I mentioned, most of it was quantum information theory is mostly about the first one where you relate information to probabilities, I would say. But both and many others are relevant for the discussion. So there's no one information.
Mm-hmm. For sure. Would you suppose that information is something fundamental or more so a description of deeper processes? So how can we kind of conceptualize its role or or even physicality, if you will?
Yes, I mean, it can be both things. So certainly when I think of the information on my hard drive, then there's nothing fundamental about it. Fundamentally, it's a bunch of magnetizations of matter. So when people talk about the ultimate relevance of information in physics, then they typically mean something more, maybe even more vague sometimes. So sometimes the use of the word information just means, let's go away from the idea that the world is just made of things that move and collide, like the classical particles. Maybe it's more abstract. So maybe the world is more made of things like patterns and correlations and things that we typically associate with information theory. It's less, it's sort of immaterial in some sense, right? And people disagree on what that means. But certainly if you take this kind of table that I have here, yes, it looks like a bunch of matter, but then our modern theories tell us if you zoom in, then most of it is actually empty space. And you have the nuclei and the electrons, and electrons are best understood more like probability waves than the kind of actual substrate and oomph and matter thing that we intuitively would imagine as humans. And so I think the word information is a sort of signal of going more into a direction where we talk about an abstract way of viewing physics that doesn't necessarily be material. It can be substrate independent, perhaps.
I think it's a good segue to get into algorithmic idealism and really the perspective shift you're proposing. And please correct me if I misrepresent in any way, but from my understanding, really the premise is that instead of an objective external world giving rise to observers and observer states, the observer states are what give rise to the appearance of an objective world. Can you please sort of explain that premise and just the overall philosophy that you're proposing?
Right. So as you already explained, I'm not claiming that the world we see around us is not real or just an illusion. It's more a claim that it's not fundamental, and it's a different approach where you start, with the first person, it's like with some self or some sense, with you, right? Now you may say, why should you do that? Certainly in the history of physics, we haven't done this for hundreds of years, and it was good that we didn't do it. It was very important to kind of ban the physicist and the observer and the human from the picture, because that allowed us to come up with objective science and with methods that try to put out, like, be as observer independent as possible. We want to experiment, they should be repeatable no matter who does them, for example. But I think that now we run at a point where this methodology cannot answer all questions that we would like to address. At least the kind of hypothesis that there is all to it, right? So we have puzzles in physics and philosophy that have to do with what would I see in this or that exotic situations where physics cannot answer. And algorithmic idealism is there to make predictions for these sorts of situations where you don't get predictions from standard physics. I give one example in a recent essay that just appeared, I think, 1 week ago in Foundations of Physics. It's a science fiction story, and it's the idea that some person, is terminally ill, and he made a contract with a company that promised to, scan his brain in all detail on a computer after he passed away. And now he's lying there and wondering, what if that happens? Does it mean I will actually wake up in the simulation or not? Right. So what will I experience anything? And if yes, what in a week from now, right? That would be the person's answer. Physics cannot tell you the answer. All that physics tells you is, there's this material body lying here in the hospital now. There's this other material body, this computer, how it's working, how the electrons are moving around in a week later. But it cannot in principle answer this question. So this question, what will I experience next, is sort of the leading question for algorithmic idealism. The hypothesis is that this is a fundamental question. And certainly quantum theory is a big motivation for it. And quantum theory also cannot really say, is the particle go this way or get that way? But you can ask, will I see the particle actually hit the screen here or there? Right? So this is the beginning and the motivation for trying something like that.
would you include any observer participation in that process? Sort of perhaps like a cubist approach. How much would you factor in the actual observer themselves in that interactive process?
Mm-hmm. So I think that this is something that's distinct, different from the cubists. So I don't think that to be able to perform an action or to make a choice is necessarily something that must be part of fundamental physics. I think it's an important part of our lives, certainly, and maybe for some experiments that we do. But you may imagine situations where you have no choice. You just wait and see what's happening, right? Same question can be asked, for example, in classical physics. Classical physics basically gives you equations, how everything moves on, like how you see what the billiard ball is doing. You could ask the same question. Now, if you're a classical physicist, what about the observer and its actions on the world? Then the answer would be, yes, effectively, you can talk about it, right? They say, maybe you think of setting different initial conditions, let it run here or there, right? And then you work out what the different consequences would be. But I don't think this is a fundamental aspect of physics. And that's what's different and what the cubists wouldn't want to say, I think.
Mm. And I understand that your theory is non-deterministic, if I have that correct. So do you factor in, I guess the question is, do you factor in agency in this process, or how could, I guess what I'm trying to ask is, if it's not necessarily as involving of the observer, then where would something like free will come into play in a framework like that, if you have any thoughts on that aspect?
Yes. So for free will, my position is pretty similar to that of people like, say, Daniel Dennett.
Okay.
Maybe Stephen Wolfram is also a person to name here. I have some overlap, but not everything with his views. But Daniel Dennett, even though I disagree with some other things Dennett said, I don't think consciousness is an illusion, for example, but he's a compatibilist. So Dennett, I think, and many other colleagues make a good point that determinism and free will can both coincide. So there's no contradiction in it. And I think the first thought in that direction that may help some people to appreciate that thought is to say, well, why should randomness help? Randomness, if it's indeterministic, the world is indeterministic, then this doesn't make me more free. So, for example, I could be a slave to a die, right? Maybe there are a couple of dice that are thrown every second. If they show 6, I have to turn left. If they show 3, I have to turn right. Right? That doesn't make me free. It's unpredictable, but it doesn't make me free. Yeah. Similarly, determinism doesn't make you unfree. You have to ask other questions. For example, are you the source of your action in a meaningful way? That's something that philosophers discuss. It brings us in a bit of a separate direction. So it's not something that's directly part of algorithmic idealism, and a bigger story, right? I'm not an expert in that either, but just count me as a compatibilist, if you will.
Got it. Well, I'd love to segue further into your theory then and talk more about the concept, or more the mechanics of universal induction and the core aspect of kind of how this process works, if you don't mind breaking that down as well for the audience.
Right. I mean, universal induction is just a mathematical tool. It's not the theory itself that I'm proposing. So it's a tool that's used as a kind of model for how you might learn and predict the future. In particular machines. You might think of a simple machine that just, looks somewhere in the world, records stream of bits, and then maybe that robot or so may just want to predict what the next bits are. Not so far away, perhaps, from the intuition we have about large language models, but still mathematically simpler. I'm not directly fitting this. And you might want to say, well, suppose I've always seen 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. A rational machine should predict that probably 0, 1 comes also next, right? So that's induction. You try to, from patterns of what you've seen in the past, you try to make a good guess about what you expect to see in the future. There are many different ways in which you can do that. Science is sort of built on the premise that this works, right? On the assumption that this works, right? And so what we observe today should be valid tomorrow. Like the laws we find today should still hold tomorrow, but it's just hypothesis. But universal induction is a certain way to formalize it. It's a specific method of induction. You say, if you've seen a certain data until now, what data should you predict next with which probability? And this tool is also used in algorithmic idealism, but it means something else there. It's just the mathematics of that that's used. I'm not claiming that there are observers that are actually predicting the future. I'm just using it to sort of extract a probability law by using the mathematics.
And one of the questions I had really when I was reading Law Without Law, the paper as well, was how to make sense of, or even if you have any thoughts on what is objectively out there, if there is an external world to some degree, even though it's probabilistic in terms of how we all are perceiving it. What do you have any ideas extrapolating onto what that external world is?
So I should say that this approach that I have, it starts with the self, so only with your state. So think of that as like the abstract data that you hold, but only locally you, right, in some sense. And from that, there is a probability law of what's next, right? So you see, oh, given that I see all this around me and what I remember, and now I might want to predict what I see next, right? And the claim is that you should use this sort of probability law that comes from universal induction. That's essentially all there is to it. It doesn't mean that you have to do that. It just means that what happens to you will probably be of a kind that follows this universal probability law. And now you can just sit down and work out the mathematical consequences. What does it mean? Well, it means, for example, that if you've seen a certain pattern for a long time, that the pattern will tend to remain. Why? Because induction works that way. The pattern you've seen in the past is something you assign high probability to repeat itself in the future. That's ultimately the reason why prediction of this approach is that you see law-like things around you, right? And when you work out more clearly what that means, then it actually means that what you observe, what your state is, looks as if you were embedded into a larger process that you may call an external world, right? Where you're just a part of. You don't have access to all these other variables around you, but you can still, or somebody else could do that, maybe could use it to predict what will happen to you. So for example, I can, predict that tomorrow I will wake up and see something bright in my eyes, right? Why that? Because I have this mechanistic model of this world around me and the sun and the earth moving, and then the sun shines in my face and so on. So, or I say, what's my state now? And now use universal induction to predict what will I see locally next. And then you see, well, I see sunshine, right? So in some sense, the external world here is a sort of emergent model. So it's a provably good approximation to what you will see. So it will, after a while, just look as if there was an external world around you. In a similar way, if you say, put lots of molecules in a box, right, water molecules, and it will look like a fluid, right? So you don't have to add anything other magic, and it's not that the fluid itself is something different than the molecules. But it's also true that, yes, there is water, and yes, it is a fluid, right? Similarly here. So the external world is not it claims to be not real or something, but not fundamental.
So, in other words, are we giving the properties or the contents of that sensory experience based on our priors and what you're suggesting through induction? Is that a process that sort of we're creating?
So you can think of, it's important to clarify this. Yeah, this is a good point that you make. So it's not that I predict the future and then voila, the future will be as I predicted. No, you can think of some observer or agent that's so stupid to even predict. Yeah, take a frog or so, or some other maybe non-biological bunch of data, right? There's nobody there that would actually make a prediction. Still, my approach claims that there's a probability law that tells you how that will evolve into something else next. So that what the frog will see next, even though the frog doesn't know what probabilities are or how to do induction, right? Or, I mean, yeah, a bunch of data that's just recorded somewhere that doesn't even try to predict in any way. So, it's not epistemic in the sense, how does an observer that doesn't know everything really predict its future? It's a claim of a fundamental probability law. What will probably happen to you if you are that thing? It's just the mathematics is that of universal induction. What will probably happen to you is whatever some hypothetical, fully rational third party would predict if they did universal induction. They would think, oh, this thing here, that looks as if it were embedded into this like Earth and the planets and the stars. So probably next it will see like the sunrise, right? And we'll see sunshine. So, and universal induction tells you that doesn't mean that you are actually doing universal induction. You may not do any induction at all.
Interesting. So just to dive in on that a little bit further. So if to really kind of pinpoint the source, so if we're not doing universal induction, you're saying that's more of a universal process. It's not necessarily native to each and every one of us sort of creating this reality through that induction. Does that question make sense?
So yes, it's not about every one of us actually creating reality. No. So I should say I really also reject some sort of like mystical ideas around that. Oh, the world is what I make of it. There's nothing like that here. It's more a sort of surprising phenomenon that when you claim this probability law for like a small bunch of information that sits there, it look like as if it was embedded into something bigger. And that's ultimately, I think, what you need to make sense of idealism one way or the other. Idealism, if it doesn't talk about consciousness, I don't directly, but if it talks about some subject, the self or whatever, you need to make sense of why is it not a miracle that there's this law-like world that seems to be there in addition, right? And so what I think is that these sorts of statistical properties of algorithmic information theory can do that for you. They predict something like that if you use that mathematics of universal induction.
And that's where I was going to go next, is how everyone's perspectives agree through this process. Do you mind shedding some light on how we all end up with the same seemingly congruent objective external world, although it's probabilistic in nature?
Yes. So in a way, I mean, you open the paper, there's lots of mathematics, and then you prove this as a theorem. But let me tell you a story, right? The story, again, is just something like humans try to tell. It's not part of a theory itself, but it's a handy picture that you can have in mind. I think of it. So suppose you're actually dreaming, right? So you're walking around and look around, you see trees, you see stones, but it's just a dream. And then you meet your friend in the dream and say, "Hi, Jim." And Jim says, "Hi, Jared. Wow, isn't it nice here? What beautiful colors." And then your friend says, "Yeah, indeed, really nice colors." And then the next day you wake up and you tell each other what you dreamt, and it turns out you dreamt exactly the same. So Jim dreamt that he was in this dream world and so Jared was talking to him. So in algorithmic idealism, it's like a bit like everybody's dreaming, but the dreams are correlated, right? So it's when you just think that it's real, then it's handy and it makes the right predictions because so as I said, like one prediction is that you see the stuff around you, that's something that looks like an external world. Then you can point at things in the world that look like other observers too, like Jim, right? Oh, this thing here over there that looks like there's this brain and lots of data stored in it. And what would it be like to be Jim, right? And well, then you use algorithmic idealism and ask, well, if you were Jim, you should just look at Jim's state and use universal induction to predict what Jim would see. And the answer is the same world as Jared. Why the same world as Jared? Well, because it's a very good compression. It's a very simple description, high probabilities of Jared's and thus also Jim's observations. So there's this theorem that sort of tells you that not just that there is this dream of an external world, but that it's kind of coordinated or correlated with all the others that we see in the dream in some sense, right? So there's a sort of emergent notion of objective reality. Certainly you can ask about other beings that are not in your dream, and they will have their own dream. Yeah, so you see that there's a quite different picture of the world, and it sort of may invite a kind of many worlds picture, if you want, or story that you want to tell, even though it's not part of the formalism. Yeah, but these are, so the thing that we agree on essentially seeing the same reality around us, it is a prediction, it's a theorem that's proven within the formalism of algorithmic idealism. It's not assumed. Classical physics just assumes it. There's this one world, we're embedded in it, certainly we see the same world. Here, this is not, so it's something you have to reconstruct. You have to say, yes, I don't assume it in the beginning, but to very good approximation in everyday life, in most situations, that's what we have. Except there are situations where you don't have it. So it's just an approximation. In algorithmic idealism, it breaks down sometimes, but that's another story, and I'll stop here.
Well, that's actually a question I was going to ask is, given that it's more, I believe, asymptotic and not necessarily 100% in agreement, where would be the situations where they would not line up?
One sort of example that I sometimes give. Okay, so I mean, the shortest answer would be, if one of the agents loses lots of information, maybe, lots of your recording of your brain gets destroyed, then universal induction doesn't know what to do. So you can already see that, when you die, perhaps, right? but here's a more concrete example that you can work out more technically. So suppose you have a very big computer tomorrow in the science fiction, right? And so you simulate the science fiction world on your computer. You have the simulated human on your computer that goes to work every day, and you observe him. Yeah, I mean, Jack, right? Simulated Jack, works in a grocery store, and it's like watching a movie. You really watch what Jack is doing every day. Now you can ask, what if I were that pattern here that's in the computer simulation that's like Jack's data, right? What would it be like to be that thing? And the answer is pretty much what the simulation shows. You would look around you would see a grocery store where you work, and you could go home to bed. So there would be agreement, right? So what you think that thing is seeing is what the thing is actually seeing. There's a sort of agreement between perspectives. But now suddenly your son comes to play with your computer and thinks, let me try something. What if I intervene in the simulation? I just randomly do something very weird and unexpected. So I put like a big pink elephant into, in front of the moon of that simulated world, right? And then your son watches the computer shows the simulation, and Jack looks along the street and looks up and thinks, what the hell is this? Now, what if you're Jack right before that event, just shortly before that event, you decide to leave your grocery store and walk home. You haven't yet looked at the moon. What should you expect to happen to you according to algorithmic idealism? Well, the answer is business as usual. Like the usual simulated business should just go on as before, because that's what algorithmic information theory assigns highest weight, right? You should have almost zero probability that there's suddenly this like pink thing in front of the moon appearing, right? So, however, for you that you watch the simulation from the outside, since you've done it, you've really intervened, there's probability 1 that this guy will see like the simulated moon, right? So suddenly you have this disagreement between the third person and the first person perspective. It is, you could say, like, that's the last thing I say here, right? But one colorful way to describe it, if you're outside and look at this, you'd say, oh, my friend Jack has just fallen out of the simulation. It's just like fell out of this world somehow and has been replaced by some other unlikely, close to zero probability Jack. So that's a sort of example.
Well, speaking of simulation and of course everything we're talking about thus far, I mean, would you view that reality as fundamentally computational? And what is your perspective on some degree of simulation theory. I don't necessarily mean full on the Matrix, but what would you, how would you approach that?
Mm-hmm. I think it's extremely important to recognize that the world seems computable in some sense. I think this is completely underappreciated. Like some people have appreciated, but I think it's absolutely remarkable. So, I give you a description of an experiment, and it can be as intricate as you want. You give it to the computer. You can run, in principle, a computer simulation. It tells you what are the outcomes, or at least the probabilities of the outcomes of this experiment. There's an algorithm that can do that. And everything we know about physics, all the laws of physics that we have discovered, are of that sense. So this is that a physical version of what people call the Church-Turing thesis seems to be true as far as we know. And this is really remarkable, I think. And that's also underlying my approach, because that's what guarantees in my approach that it's consistent with physics as we know it. Now, does that mean that our world is simulated? How soon about the simulation hypothesis? No, it doesn't mean that. And algorithmic idealism also tells you that it may not even be a well-defined question. For example, when you have this point of view that I'm trying to defend here, you wouldn't even say that there's an actual base reality sitting here, right? Which is this universe and not another one. And that's like actually what things are. And then you ask, or is it actually different? We have another base reality and we're just simulated, but the simulation is perfect. No, because ultimately it's just your state, which is a pattern, and that's fundamental. It's the same in both cases, right? So algorithmic idealism tells me that both ideas are equally right or wrong, right? That there is no answer to the question of how are you actually instantiated. It's like a non-question. It's a bit like asking whether two events happen at the same time or not in special relativity. It's kind of dissolved in a way.
And in your perspective and in your framework, is it really more about the observer state and less about the observer themselves? Is that correct? Is that what I'm getting from this? It's really not even necessarily about the observer. It's really just about, as you said, like that pattern, that observer state.
Well, it's a bit a matter of terminology. So in the theory, as it's written down, there is just a thing called observer state, which is a mathematical pattern, nothing else. Now, we like to use the word observer, right, as something that's typically associated to material body and sort of persistent over time. I like to think of, even aside from my approach, I like to think of myself as more of sort of software than hardware. So I know I'm exchanging lots of matter, like I'm losing hair and, I'm exchanging parts of my body. So still I'm the same person as 20 years ago in some meaningful sense, right? And that seems more to have to do, I think, with the sort of pattern, like I am more this kind of abstract pattern or algorithm or maybe data that's relevant, that's represented in the relevant parts of the brain. Then I'm these particular atoms that I'm made of. So, and that's also what algorithmic idealism starts with. It starts with, what if you're a pattern or a bunch of data in some sense? What pattern will you be next, right? Maybe you're now a pattern that sees somebody else in front of you in a computer screen. Next, you're still somebody seeing somebody else in front of a computer screen moving a bit differently. So sequence of patterns, that's the idea. It's in this sense, it's not strictly materialistic, I would say, but it's also not directly in contradiction with most versions of physicalism, right? It still predicts that if I tweak the brain in some physical way, that yes, it will have an impact on your observer state and what you see and so on. Because it just predicts the usual picture of the world with a good approximation, including all its phenomena. Yeah.
Right. I was going to suggest as well that, yes, it predicts the laws of physics. So it's from what I've read, it's very compatible.
Just to clarify this one point, it's not a theory of everything. It doesn't predict what the laws of physics are. Just that there are some that's probably simple and computable. It doesn't tell you which ones there are. So I'm not claiming to have a theory of everything. So
thank you for clarifying. Yeah. Thank you. I want to be very precise and not misrepresent, of course. And speaking of, I'd love just to kind of get a little bit of contrast to something like analytic idealism with Bernardo Kastrup? Because there, of course, are several different versions of idealism, namely analytic idealism being one of the forefront theories people hear about mostly. How would you draw a contrast between your approach versus that approach in idealism?
I am very much interested in analytic idealism, but it's different in a sense that I see myself more as a mathematician slash physicist slash computer scientist than a philosopher. And so the sorts of questions I want to ask tend to be different from the sorts of questions that you would as a philosopher. And also, the main difference is I'm not talking about consciousness directly, right? Whereas analytic idealism and what I've read about Bernardo Kastrup talks indeed a lot about consciousness and universal consciousness and whatever. And you sort of cannot actually do that if you want to be precise as a mathematician or physicist, because it's probably a high level quantity. It's something like maybe beauty or love, right? So these are notions that are just not well defined enough to build a physical theory on them. And even if you could, it seems unlikely to me that you should. So yes, you could, for example, say, oh, now there are these mathematical theories of consciousness, like integrated information theory and others that are precise. So why don't you use that? But I think this is the wrong thing to do. I think there's something even more basic. I had surgery a couple of weeks ago. I was unconscious, but I still think this pattern was still there. So the self, in this technical sense, was still there. And as long as I can relate technically to that thing, that's enough to build or construct something like algorithmic idealism.
Does it leave room for those subjective qualitative experiences, or is that just something it's more of just hands off for now? How would you fit that in or even approach that?
Right. So I'm not addressing the hard problem of consciousness directly, and yes, it leaves room for that, right? So you could say, maybe you want to go climb up all the mountain of a perfect understanding of the hard problem of consciousness, what qualia is and how it comes about, like how to think of it in all detail. But you start here with a bare physical theory. Now, this is a big gap. The physical theory just tells you how basically particles move, right? And how matter behaves. And to some approximation, how biological beings move around in the world and whatnot, if you go to biology and so on. But you need to explain a lot to get there. Algorithmic idealism doesn't try to get there. Maybe it goes a tiny bit further up, not much, right? Because it already tells you that the view from the inside, that has to do with consciousness ultimately is something that's fundamental in some sense. So you don't, maybe this part of the gap is something that you lose. You have to explain, like, if there's just this big world, like, how come that there is something like a first person perspective to begin with? Because you start with that already, right? But why does it feel like to be such a pattern, right? Why does red look red? And why do I feel like, wow, I'm here and all these emotions? And I have absolutely no idea, but I think that's fair enough because no concrete physical theory can say anything directly about it.
So in this theory, in this framework, is the self pretty much distilled down to this sort of pattern? Is that about as far as you would describe a self?
Well, I guess you could ask, they go to physics, relativity, talks about space and time. What is an event or a space-time point in relativity? It's just a mathematical element of a manifold that you can write down 4 numbers to tell you which one it is. And then you have some other mathematical structures around it, like the differential structure and how coordinate changes act and so on. Now, if you're a general relativist, what then do you claim about the nature of space and time? What is actually a space-time point fundamentally? Well, you'd say this is a sort of different category of questions that you're not trying even to answer directly. I would say the same. So I'm not trying to say more about the nature of the self, about qualia, what it feels like. And that's fine because I don't have to, right? And I shouldn't, because ultimately I want to ground whatever I claim on as few claims as possible and as a simple model as possible. So, yeah.
Yeah, that makes sense. And kind of shifting gears a little bit, does your theory say anything about sort of the concept of emergence through, or how the process of evolution and the emergence of complexity sort of takes place in this process?
I don't think there's anything fundamentally mysterious about it where a new theory like mine would be needed. Yeah. I think we have a pretty good understanding how biological evolution evolved, and we're understanding the details of it better and better. I think the term emergence, so it only appears here by saying, here are the actual claims of a theory. Now, in this and that approximation, if you've learned a lot of data, it suddenly looks as if there was this external world. But that's just the physics phenomenon that you have a fundamental theory and you do some sort of approximation or coarse graining, and then you get a kind of approximate level of description that's also valid for many purposes, right? When you go from the atoms and molecules and their movements in statistical physics to the gases and temperatures of thermodynamics, for example, right? This is one of these steps, and that's certainly a sort of methodological step that I also have, that you can call emergence in some sense. So in some sense, the laws of thermodynamics emerge from statistical mechanics, I think, but that's not more than that necessarily. So I'm not claiming to understand emergence as a general phenomenon any better. I'm not even that much interested in it. Yeah, I would leave that to the philosophers, more or less. Yeah.
Got it. And kind of on a little bit of a different note, but on the idea of what will I see next as the core sort of question of this, on a more like, I guess, practical level, does that relate to all sensory experience? Because I'm trying to kind of ground that of like, what would I see next? And the reason I ask about emergence and like evolution, for example, is, let's say there's some, early like tetrapod or something, and it's, going through this process, right? All the way up to humans, what will I see next? Well, what could I hear next? What could I touch next? What could I think next? Is there a way to ground that in terms of what that encompasses?
Mm-hmm. So what will I see next is certainly just a slogan that tries to give a good picture of what's going on here. When you want to go more to the concrete theory, the actual maths, then you should phrase it a bit differently. You should more ask, if I'm that pattern now, what pattern will I be next, right? So, and then you can think of your tetrapod, or, very simple being from a billion years ago, hovering the ocean, and you describe it to some level of detail. There's a description of what its like cells are doing and the pattern that make up its cells. So suppose I am that pattern, right? What pattern will I be next? Right? That would be the answer. And you ask this question completely abstractly in the theory. Yeah, you say there's just a bunch of data, and it goes into another bunch of data, right? That the fact that it represents sensory data, that some of these data points are close by because they are the same body part and others are far away. These are parts of the time evolution of the pattern that you would discover if you did a detailed analysis of this unfolding of the data, right? But the law itself is abstract. So here's a bunch of data. What will happen to the data next, right?
Mm-hmm.
Yeah. And so then you can apply it to anything, right? Including certainly humans.
That makes sense.
Whatever makes them up, and or something completely non-biological. So, I mean, it's really just about patterns and the idea that it could be a pattern. Usually this doesn't mean that you feel anything. Probably we should think of most pattern as something unconscious, right? But sometimes, like us, it just happens that there is something, what it is to be like that thing. And then you can wonder yourself what's going on next.
Thank you. That's very helpful. I think I have a good beat on the perspective now. A couple other areas I wanted to explore was what your perspective would be, and how this framework would address things like Bell inequality violation and non-locality? How would it approach those aspects?
Yes, this is a very good question. So I am putting really high, let's say, mathematical or physical standards to my approach. So what I want to do ultimately is to derive aspects of quantum theory from it, rather than assuming them from the start. Lots of people ask me, "Oh, you talk about probabilities, yeah? Why not like wave functions, quantum states to begin with?" And the answer is, well, because it's an opportunity to falsify my approach. If in the end it doesn't predict these things, or at least some aspects of it, then it's probably not a good approach. And if it does, then it would be really exciting. So the idea is certainly that some of the sort of architecture of this approach resembles quantum theory's phenomenology somehow. So as I said in the beginning, in many quantum experiments, like a double-slit experiment, interferometers, or in particular in Bell's scenario, it's probably impossible to say, is the particle really here or there before you measure, unless you violate some other principles of physics, such as locality. Right? And so, but what you can always ask is, what if I look here, what will I see? What if I really measure, what outcome will I find? Quantum theory isn't deterministic, doesn't tell you what exactly it is, but it tells you the probabilities of this. And so my hope is, given that my approach is built in a way that doesn't even begin with our usual notion of world, where the hidden variables could live, that actually enter the formulation of Bell's theorem, that it will turn out that in the end, observers so constrained by this theory will see statistics that resembles those seen in Bell experiments. And I do have some preliminary results on this earlier paper, but it's not yet where I want to go. The idea is a bit, if somehow, if you forget something, then the world forgets it, right? Because the world is a property of the data that you hold locally. And this opens the door to some phenomena of statistical sort that other people have discussed to derive something like no relations. But yes, the litmus test is, can you show that there are situations in which you see a violation of Bell inequalities, but no signaling between the parties? And I would actually pose it to other people too. Others who propose new theories, derive quantum theory from other assumptions about the world or ontologies. Tell me that. That's the first thing I want to know. How can you explain this fact?
How can we conceptualize the wave function, and what would your framework, even just personal perspective, say about that?
So I think it makes sense to go away from my specific approach of algorithmic idealism and look a bit more broadly. So forget everything I've said so far. Just think of quantum foundations and all my colleagues, including Chris Fuchs in Cubism, that try to make sense of the quantum world. And there is a broad class of interpretations that are sometimes called neo-Bohrian or neo-Copenhagen that tell you in the end that a quantum state is nothing but a catalog of probabilities. So what this psi thing is not like an electromagnetic field in the world, something that sits there and that you can actually discover. Actually, we cannot discover it. Nobody's ever seen directly a wave function. You cannot directly see it, provably, right? It's impossible. But it's the thing that you can use to obtain the probabilities of the outcomes that you'll see. So it's a probability distribution. And this view, I find it very attractive, even apart from my approach, because it resolves lots of problems. Like the wave function collapse is no longer a mystery there, for example. So I would want to phrase this question in this broader context of neo-Bohrian interpretations of quantum theory.
Got it. I want to kind of explore a couple of the interesting aspects, kind of going back to your theory. One of which was subjective immortality, if I have that correct, and the other being the Boltzmann brain problem. Those are two exotic areas that are really interesting, and I'd love to kind of talk about the idea of the pattern persistence with that, theoretical immortality aspect, and if you don't mind shedding a little light on that aspect.
Yeah, so these are to distinguish these two a bit. So the Boltzmann brain problem, let's quickly talk about this. is a problem raised by cosmologists, where I would say that my approach has a pretty clear answer and resolution to it, right? As I said, this is all work in progress. There's this general idea of algorithmic idealism and its main assumptions. You can differentiate it and formulate it in many mathematical ways. But regardless of how you do it, there's a pretty clear message about how to understand the Boltzmann brain problem there. For those who know it, the answer is just don't count Boltzmann brains because the number doesn't matter. Right. The other question that about subjective immortality and so on, I want to reframe. So, I mean, it depends on the exact model of algorithmic idealism, right? I have a very simple model that I put down so far, but it's not yet the final one, right? But so I cannot say much of that. And I would rather want to say something else. And this is the idea. So something is lost, something about the picture of our picture of the world when we use algorithmic idealism in particular. And that's this idea that, you have this like library of all possible worlds, right? And then God or randomness or whatever just picked one of them and instantiated this real world. So there's this real world, maybe it's a multiverse or I don't know, whatever, it doesn't matter. This real world and the other ones are not real, right? But it's this real world. And we're just lucky. We're incredibly lucky that we have been instantiated in the real world. There are all these possible beings, right, out there in algorithmic idealism language, and there are observer states that have never been realized, right? And that the poor beings will never exist, right? But this is rejected here. There is no notion of like physically distinguished existence of a property that something could have. So all possible modes of being are sort of realized relative to themselves. Think of some possible being, and you won't see that in your world, but there is something what it would be to be like that. And there's nothing about you like some magical or breath or that made you real and the others not. So it also means when you create, say, a baby is born in this world, or you create a robot or some other data collecting machine, it's not that you created that thing really. It's sort of you enforced condition that allow us to communicate with it, right? It's a bit like, you go into your kitchen and you put on your desk, you put 6 eggs in your basket, right? Now, does this mean you've created the number 6? No, you've just instantiated it. The number 6 is just something abstract. It's an abstract pattern. It's a natural number. Similarly here, this kind of observer states or self states are abstract patterns that you don't have to create right from nothing or so. They just exist mathematically, and that's enough. So that's the sort of view that underlies all these questions of survival and existence that underlie this broad class of questions.
And I'm more on a meta level. If you have any particular thoughts on a bit more of the kind of meaning side of this, and what I mean by that is how people can sort of ground this perspective and how it might impact the way they live their day-to-day life and their perspective of their role in the world of the world. How would you say that this affects the kind of standard paradigm of what someone's existence is?
Yeah, I mean, there are different possible answers there. One is, when you think of the universe at large, then it may shift sort of the kind of ethical emphasis that you put on certain decisions, perhaps, right? So there's a community of people that has been associated with the rationalist community that have pointed out that humanity might, in a couple of 100 years or so, colonize the galaxy, and even further than that. And so we should do what we can to make this happen, because if it happens, then there will be, I don't know how many, 10 to the 40 human lives that may exist in the future and lead valuable lives. So it would be a really ethically extremely bad not to do everything we have to avoid existential risk, for example, right? And this might bring you, for example, to spend more money, say, on AI alignment. You should spend lots of money on AI alignment, which is an important problem, but say more on these kind of questions of what happens in 1,000,000 years from now, rather than sending mosquito nets to Africa right away or so, right? And so these are questions that are debated a lot, and whatever position you have, I'm not advocating any particular position here, but your position would certainly be informed by your picture of the world, and thus probably changed if you hold a view that's more akin to what I'm proposing, which is that we shouldn't think of this kind of singular one universe that came to existence and then being complete void if we mess it up. It's a very different view of the world, right? For your everyday life, certainly, if you think of death differently, this may have a profound impact. But I want to be very careful there. I want to clarify that I make really nothing of mystical claims or religious claims here, right? Nothing like that. And I also say that whatever you believe about this phenomenon, according to algorithmic idealism, depends on the details of the mathematical formalism, right? But there are some versions of it where it just so happens that it turns out that process of death is an example of what I call probabilistic changelings. Example, like when you go back to the simulation example, where somebody just falls out of the simulation because you alter the laws of physics, that would be a sort of metaphor for what might happen in this case if, a brick falls onto your head or so, right? You lose lots of data, including this about your external world, and so universal induction will then not predict this world anymore with something else. So this objective reality that we agree all on what we see, which is just a theorem, algorithmic idealism, it holds to good approximation. This approximation would break down in these situations, and we would diverge and see very different things, perhaps. Yeah. I want to do more work of the mathematical sort before making any strong claims there. But it underlines that this sort of thinking may lead to profound changes in how we view ourselves and our place in the world.
Absolutely. And then on an extension of that, and I know and I respect how precise you are with the mathematics and your approach here, but if you had a perspective also on another individual, Michael Levin, who is putting out some incredibly interesting work in regards to like bioelectricity and showing these sort of, even you could call like Platonic patterns, and sort of how, or I should say with like the planaria, for example, where they show the electric face and they have the actual worm, you can see it in the imaging, and then it regenerates to that pattern. And there's sort of these Platonic space sort of patterns, if you will, said very, very roughly. But does this sort of idea of patterns that are instantiated in reality, I mean, could there be a potential for some type of kind of Platonic space where these patterns sort of live, where they are instantiated into this sort of three-dimensional world that we live in?
I'm not familiar with this particular approach, so I can really say nothing about that. I guess I am pretty skeptical to say that, first of all, in general, about the idea that you can do experiments nowadays that would sort of in themselves undermine our picture of reality very strongly. I guess we have experimentally probed a lot, and this has told us already a lot. So, for example, I believe that things like extrasensorial perception and many other claims that people are still trying to do experiments, it's all complete nonsense. That's my personal perspective on it. I may change my opinion one day after like hundreds of well-done studies have confirmed it to overwhelming statistics. But so far that haven't. What I'm proposing is an approach that claims directly that in almost all experiments, maybe in all of them, that we can actually do intersubjectively, there's no deviation from what we expect. Everyday life and the usual picture of the world is a damn good approximation. even more mainstream approaches that claim departures. So new particle types that people claim beyond the standard model of quantum gravity. Even those are completely out of experimental reach at the moment, as far as we know, up to some clever new ideas, perhaps. So I'm in general skeptical about this idea that there are experiments in the near future or that we can do on a desktop today that will overthrow our picture. But maybe what I say doesn't even apply to the example that you've given. So I apologize if not, but I'm just not
all good.
familiar with
Yeah.
that approach you mentioned. No.
Yeah, just trying to connect certain dots and looking at different fields. But you should definitely look up Michael Levin. He is an unbelievable biologist at, I believe, Tufts University, and he's putting out just some unbelievable work, kind of about morphogenic fields and how sort of, especially in planaria or things called anthrobots, which are basically human tracheal cells that they put in a petri dish and they exhibit novel behaviors. And essentially, this is definitely a very rough explanation. So, obviously go look at the research directly, but they're able to essentially do things like even repairing neurons if they leave them on these sort of neuron junctions, so like completely just novel properties you'd never expect out of certain types of cells, showing that there's sort of an intelligence that may not just be strictly native to the DNA and to the actual sort of mechanism itself. So anyways, that's just kind of where I felt that sort of like the idea of patterns could somewhat be connected. But no, that makes perfect sense. For me, I'm just always trying to understand, where's the source, and it's totally fine if you don't have or you wouldn't even like to make a claim on that, because I totally understand, because that's where you start getting into definitely philosophy and a lot of the areas that are not nearly as technically precise. But if I could ask Markus the man, and maybe not necessarily the rigorous scientist and researcher that you are, or perhaps both, what do you have, if I may try to get a little bit out of you in terms of what you think sort of the source of this reality is, or of the patterns, or of even of consciousness itself? Do you have an itch one direction, even if it's just like a hunch?
I should say right away that everybody should be a skeptic. Nobody should trust me. You should trust my theorems, but not what I think. But you can listen to it. I can tell you what I think, right? And it's I'm pretty agnostic about many things. But I guess I would say there's a primacy of, I tend to think of mathematics, of structures, of logic also as primary. Yeah. Mathematics tells you all the possible ways in which there could be facts that are not contradictory, right? All possible worlds, if you want. And this underlies everything in some sense. I believe that. Right? Now, in what sense exactly? Now, I'm not interested in putting out a philosophical view about that, because I feel most of the progress in the last decades has been coming through rigorous math like Bell's theorem, that people are really proving something. So I want to build a concrete theory. Like, it's just what I want to do. Right? Certainly, I believe that whatever we find will be absolutely fascinating, right? So I'm not a dry person who doesn't want to ask these questions and just do math. I just think it's the best tool we have not to fool ourselves. It's like, when you have a child that's ill, and, you're completely emotionally involved in helping the child. Yeah. Then for a while, you have to set your emotions aside. You have to give it to a doctor, and doctor is a surgeon, like with hard instruments, right? And instrumentation that is scientifically completely rigorous. But by using that, you arrive at an endpoint that is wonderful, and that's emotionally super satisfying, right? Because you do the right thing. And so I like mathematics for the role it plays in us not fooling ourselves, and that's sort of something that stops me sometimes in making too much speculation, perhaps, right?
Yeah, absolutely. No, I totally respect that. And yeah, definitely the rigorous processes and research and progress is absolutely the foundation of everything. So, yeah, thank you for the work that you do and the field that you work in, because it's just, so critical to the advancement of our understanding in general. And I think really the last question I would ask you before we conclude here is just, what are the most exciting things that you guys are working on right now? Like where is this research going? What's kind of the game plan moving forward over there?
Well, I guess one thing we've worked on a lot is a bit different stuff in quantum information theory, quantum field theory, quantum reference frames. We've put out a new proposal why there are no only bosons and fermions in the world and no other particles, a possible information theoretic proposal that I'm excited about. It's mainly worked by my student Manuel Mekonnen. And we're thinking more about quantum reference frames and all these topics now. Regarding algorithmic idealism, at the moment, I'm going one step back and I try to understand the Church-Turing thesis a bit better, because that's what underlies lots of it. So I want to understand in a bit more detail in what sense is our world computable. So if I just know a bunch of data in some small region, what can I infer from it about the rest of the world, for example? In what sense can I really predict with an algorithm what the outcomes of an experiment are? How does it depend on the physical theory? So this is something we're looking at now. Again, something where there's surprisingly little research. Even though I find it one of the most remarkable facts we've learned about our world is that it's, you could say in Wigner's words, that's miraculously mathematics applies very well to it, but in modern language, it's computation in a way, it's computability that even allows us to do physics in the first place. So this is something I want to understand better, something I work on at the moment. And certainly there are some algorithmic improvements of the models of algorithmic idealism, also something among many other topics. So we're also just looking at quantum foundations questions. We've just published an experiment where we see decoherence in a superconducting qubit. So we do lots of different things that we're excited about. We talked only about one of them today. But yeah, I'm really happy that I have this team that can look at these questions. Yeah.
Absolutely. Well, what would you say is your if you had a home run goal, such as in 10 years, if we solve this, I will be ecstatic. Do you have something big picture like that in terms of goals?
Well, it's a good question. I had that for a while and I thought like one day I want to derive quantum theory from simple principles building on Lucien Hardy's work. Now we achieved it and some other groups did this as well. At the moment, I feel like I have several ideas that I want to advance. I would be extremely excited. So I would be really excited, certainly, to improve algorithmic idealism. The model has some disadvantages, as I mentioned in my paper, and I want to understand this better. I just feel super excited to think more about quantum field theory with lots of people here and many postdoctorally and Blavatsky. So I find like many topics exciting. I think I would be also really happy just to have people around me that share this broad view of information theory, and I already have to some extent in the quantum foundations community. So you already see a happy person in front of you, even if nothing more in the next, well, there will be something more in the next 10 years, but I'm already happy about being able to be part of this community that tackles the biggest questions, most fundamental questions out there, and actually being able to get money for this.
Yeah,
this is wonderful.
That's the dream. Yeah.
And I have a wonderful team here of people and really great conditions at this institute. So yeah, you see a very happy man, and you'll see what comes out in the future.
That's so inspiring. Yeah, that's really it, right? Is you get to live out your true passions and do it and get paid for it, so that's really it right there. So yeah, congratulations on all the work you've done. Thank you for the work that you've done for humanity's broader understanding of reality, which is, I would say, is quite important. And perhaps the last thing I would want to end on is if you had any advice for the lay audience who are inundated with theories of consciousness and reality, and there's many worlds, and there's cubism, and there's untold number of different models of reality, of consciousness, etc. What would be your, I guess, strongest parting words of advice for how to kind of approach this understanding and how to sort of discern information and just, I guess, words of advice when trying to understand these sort of areas?
Yeah, I mean, there's certainly a general skill of checking your sources, like what can you trust and what not. And everybody knows that it would be good to develop skills in this direction. But my advice would, I guess, be to say, listen to those people who are honest and saying what they don't know, and who are honest in saying that what they have is just a thesis. And try to distinguish between what is really consensus in the field and what is not. Algorithmic idealism is absolutely not consensus in the field. That's what I'm doing now. It may be completely wrong, so don't take anything of it as like life or death. I mean, certainly not. But in general, I think it's often the case that the people who are trustworthy are often also not necessarily the loudest ones. Anyway, but yeah, humanity doesn't know the answer to all these questions, and if somebody claims they do, then please be skeptical. Yeah.
Wise words. Absolutely. Well, Markus, thank you so much for your time this evening. It has been an absolute pleasure. And I know the audience is going to get a lot of value getting the opportunity to really hear you directly kind of break down these aspects of your theories and general perspective. So, Markus, thank you so much again for the time. It's been such a pleasure.
Thanks again for having me.
Thank you for tuning in to this episode of the Quantum Theory Podcast. If you desire to embark on the path of self-mastery, visit quantumtheorypodcast.com to join a like-minded community of purpose seekers committed to personal growth.